Um, we probably won't get through all of those, but by that time, having gone over the quiz, you should hopefully be ready for the test tomorrow. So if you look at the bottom at the results, first one, number 1, this was only 33% correct. You are starting to save for college in 2019. You deposit $2,000 into a mutual fund that compounds continuously. What does that tell you? It means it's this formula here. That is the formula for continuously compounded interest. Find the balance in 2023. So the amount is equal to the principal, which was 2,000, times e to the power of the rate, which is 0.023, times the time. If we started in 2019 and we check the balance in 2023, how much time has passed by? 4 years. That didn't sound good. All right, so you could put that into the calculator all at once. I always hesitate, but like I like to break it up into pieces because some of you don't know how to put too many operations at once. But here, let's go. I'll live dangerously. So 2,000 E, then 0.23 times 4. 2192.73. Yet 67% of you guys got that one wrong. Now here's something else I found interesting, right? I'm almost certain if you were to ask any Algebra 2 teacher in this unit what they would consider to be the most challenging, like the most demanding skill, I'm pretty sure they would tell you equations. Okay, but if you look at the results from the quiz and then also the practice test yesterday, I don't believe that those like stood out as being missed the most. If anything, the ones that were missed the most were the word problems, okay, and some of the ones with properties of logs. Again, everybody has their own opinion, but if the consensus is that those are not supposed to be the most challenging, what does stand out about those? What stands out about the word problems and the properties of logs? They might not be the most challenging, but what are they? They're the most distant. It's what we covered the longest time ago. And if that's true, I don't know. I don't have any hard scientific data to back it up, but if I'm somewhat right about that, what does that also indicate? If we're struggling on the things that we learned the longest time ago, what does that indicate? Come on, just shout it out if you know it. You don't have to be afraid. Well, that's the point I'm making. Is not that it's necessarily hard, but if it's the stuff we learned the longest ago and that's what we're struggling with, yeah, probably the studying is not where it needs to be, sure. All right, so any questions? No questions on that one? Number 2, 52, so slightly more than half of you got this one correct. And there's zero amount of work here. They give you the function and they want to know what happens each year. On the homework, there was a few modules that said, what was the wording of it? It was like interpreting. I think it said like interpreting exponential models, interpreting. If it had that word interpreting, like they were just asking you about pieces of a function and what it meant. So if they want to know if this is increasing or decreasing, that's the number right there that would tell you that. That 0.92 is called the growth or the decay factor. Is that number greater than 1? No, it's less than 1. So what that tells you is that this is a decay. Decay means that we're decreasing. So I would hope not one person in here put C or D. But I know that's not the case. Now maybe a slightly harder question. Hey, Soph, I didn't know you were here. Hey, didn't see you this morning. We'll talk later. So what would have been the more challenging part is what did we decrease by? And so you see that 92 there, and you're like, oh, you're decreasing by 92%, but that's not the case. The 92% is what's left over. Okay, this number 92, if you look at the formula, came from that 1 plus r. That rate is what you're increasing or decreasing by. Did you get all? Oh, you have all the other papers? Okay. So what are we decreasing by there? 8%. Yeah. The way that we got that 92 is by taking away 8%. 1 minus 0.08. So it should have been B. You had one just like that yesterday on the practice test too. Number 3, if there are initially 200 bacteria in a culture, this is the one that I would say, okay, fine. If you got everything else right, but you missed number 3, then you have my stamp of approval. It was, this is just a little bit more challenging than the rest of them, and but a lot of you just, instead of using the function, like that's why it was still 50% correct. I think you just did it by hand, like instead of using an actual formula. If there are initially 200 bacteria in a culture and the number doubles every 2 hours, how many bacteria are there after 6 hours? So what you guys did is said, hey, if it's doubling every 2 hours, in 6 hours, it's doubled 3 times. So you just did 200 times 2 times 2 times 2, and then got the answer that way. I mean, I guess it's multiple choice, but it could have also been done with a formula. The initial amount is 200. If it's doubling every 2 hours, that's the growth factor. Because you got that from 1 plus an extra 1, like 100%. If something is increasing by 100%, what's it doing? It's doubling. 1 plus 1 is 2. And then the tricky part, another tricky part of using the formula would be, well, for the time, you're going to be inclined to put 6 hours. But the thing is, it's not doubling it's not going to double 6 times. It's doubling every 2 hours for 6 hours. So how many times in reality did it double? Yeah, so there was 3 2-hour increments. So the time would be 3. And if you put that in the calculator, you get 1600, I believe. Let's see. 2 to the third is 8. 8 times 2,000. Or sorry, 8 times 200 is 1600. Number 4, this was 37% of you got this one wrong. A little bit more than 1 out of every 3. Jeff invests $1,000 in an account that pays 4.25% interest compounded monthly. So the first one we did was compounded continuously. This one is compounded monthly. Which formula are we going to use? The other one there. Good enough. Find the other one. The one on the right. So and then how much will he have at the end of 4 years? So the amount at the end of 4 years is equal to the initial amount, the principal, which is 1,000, times 1 plus 4.25% is 0.0425, divided by, what would the number be for monthly? Yeah, 12. To the power of 12 times the years, which is 4. I ran out of space there, but or you could just put 48. I like to break this down into pieces. This one I'll do by pieces. So let's do 1 plus 0.0425 divided by 12. So that decimal represents what's inside the parentheses. Then order of operations tells me I got to do power next. So 4 times 12 is 48. I'll just put 48. Be careful there. I could see somebody putting power of 12 times 4. And what that would do, order of operations, is it would take it to the power of 12 and then multiply that by 4. So it's just safer to do things like for you to handle order of operations. And then that times 1,000. And 1184.95 D. Yash, you okay? Hang in there, buddy. Weren't you saying that you couldn't see the board? Weren't you saying that you couldn't see the board? You can see it even without the glasses? Any questions so far? Okay, number 6. This one was somehow missed by 42% of you. Almost half of you missed this one. And if you really feel that I didn't go over this, please let me know. I like to prove a point. I mean, I'll go back and show you on the videos. Just get a log and rewrite it in exponential form. This is also all over Khan Academy on the homework. The base stays the same. What's the base here? 4. Whatever you were taking the log of is going to jump to the other side of the equal sign. So that was the x. We probably won't get to it on the practice test, but there was one. If you look at the packet I gave you, it again missed quite a bit, and it was the very last one. But that one was going backwards, right in logarithmic. Oh, no, you had both. If you look at the packet I gave you, the last two, rewrite in exponential form, rewrite in logarithmic form. Just, we're not doing anything, just shuffling around. Okay. The next one was missed the most of anyone on the entire quiz. Only 10% of you got it right. I think maybe 2 people got this right. Maybe 3. How many? 5? Did I count? 1, 2, 3. Okay, 5. Yeah, my bad. Because it would be, yeah, sorry, 5. So 5 people got this one right. How would you expand a log? Well, we got to use our properties of logs. First property you would use is quotient. So I would write log of x to the third minus, yeah, you kept on saying subtract, good. Log of x, yz to the fourth. Okay, what property would I use next? Well, yeah, if you wanted to keep it separate, you would use power. Okay, but really what you should be using here is a product, because over here, these can still be split. But now the tricky part here is that, look, you're subtracting this whole entire thing. So people are like, well, hey, when you use product, you're supposed to add, right? Yeah, you are. Product, you're supposed to add the logs. But then this little minus here comes behind and distributes and makes them negative, which is why, really, I think this is even easier just to do in one step. And the trick I showed you was, hey, if it's coming from the bottom of a fraction, that log needs to end up being negative. So we would say log of x to the third minus log y, then minus again log z to the fourth. And really, if you wanted to jump straight to that one, that'd probably be the better way to do it. If it's coming from the bottom of the fraction, make that log negative. And then just do power. This 3 goes to the front. This 4 goes to the front. So it should have been C, I believe. Somebody asked a follow-up question last period, said, oh, so when it's fully expanded, none of the variables should have exponents. Yes, that is correct. Those should have been moved to the front. Yes? What would what? Uh-huh. That one, how would it have looked like in the beginning? The z would have been on top. This z to the fourth, if it would have been on top, it would have ended up looking like d, because that log ended up being positive. Any questions? All right, so now we skip to number 10. 31% of you missed this one. I know we had a heaping helping of these. We did a ton of these. Man, gotta reprogram this thing. What type of equation is this? Exponential, but I have 2 different bases that are isolated. Which base did I recommend before several times for you to get rid of? The smaller one. There's more than one way to do this. If you go to tutoring, maybe they show you how to do this with common base. I could show you with common base. It's probably even quicker. But as far as uniformity goes, plus with your overall reliance on the calculator, I would just tell you take the log base 9 on both sides. The log base 9 is going to cancel the 9. This 2x is going to go to the front. So I would get 2x, and I can do change of base now, log 81 divided by log 9 equals, since the log base 9 canceled out, what is that, 8x minus 12? What is log 81 divided by log 9? It is 2, and 2 times 2x is 4x. So we get 4x is equal to 8x minus 12 minus 8x on both sides minus 4x is equal to negative 12. X is positive 3. Do I need to check for extraneous? No, why not? It was an exponential equation. Alexis, you following along? Okay. Now we go to 12. Okay, now 12 here we have a logarithmic equation. There's two ways of doing this. And I showed you both ways on the notes. Since there's two different logs, the way that would be, I'd say, more comprehensive, the way that would always work would be to get the logs on the same side and use a property of log to combine them. That's not what I'm going to do here. I'll do that on the next one, but not on here. Since they're on different sides and they're both log base 3s, if I can get them to just be log base 3s, I can make what's on the inside equal to each other. So I got to get rid of that 2. Yeah, I'd have to move it to power property. If there was something else on the other side I could divide it by, I would. But I can't, so I end up with 10 squared is 100. So I get log of 100 is equal to, log base 3 of 100 is equal to log base 3 of 4x. So since there's both log base 3s on both sides, you can just say 100 is equal to 4x. With the added caveat, I get 25, and you can look at this and say, oh, there isn't a no solution, so it has to be 25. But because it came from a log, you're supposed to check for extraneous. It was multiple choice. On the free response one, there was a log one like this. Yes, in order to get one of the points, you had to check for extraneous. I'll just do this one on the calculator. So 2 times, and I'll have to do change of base. Log 10 divided by, close parentheses, divided by log 3. That gives me 4.19. And then on the other side, well, it's going to be the same thing. It's going to be the exact same thing because 25 times 4 is 100. Well, fine. Hey, it's not okay. Here, let's just do it. Log of 100, because you're putting different things in the calculator. Log 100 divided by log 3, and you get the same 4.19. So it checks out. Yes, sir. Huh? 10 squared. The 2 goes up and becomes an exponent. 10 squared. Now look at the next one. On the left, the next one, like we have the logs on the same side. Plus, if I were to move a log to the other side, we'd be stuck with that 1 anyways. So here we're going to have to use the properties of logs. Which property of log should I use there? Quotient property. Yeah, but since you're subtracting the logs, I would write a single log base 4, and then it would be x plus 2 over 3 is equal to 1. I asked this question last period, and I heard crickets, and that's amazing to me because we went over these a bunch of times. Now that I have a single log, how do I remove the log? Change to exponential. The base stays the same, which is a 4. It's supposed to be to this power, but 4 to the 1 is just 4. And then we get that equal to x plus 2 over 3. Right, Yash? The base of the log becomes the base of the exponent. It's supposed to be taken to this power, but anything to the first is just itself. And then this that was in the log, it gets to break free on the other side. Times 3 times 3. 12 is equal to x plus 2 minus 2 minus 2. 10 is x. Because this is a logarithmic equation, you're supposed to check for extraneous. I could tell based on the fact that it's multiple choice. And see, if I would have written this, I would have put no solution as a possibility to force you to check. But I mean, you can tell the answer is going to be 10. If you want to check though, first would be let's see, 10 plus 2 is 12. So log 12 divided by log 4. No problemo. But then we have to subtract that from log 3 divided by log 4. And if I did it properly, what should I end up with once I hit equals? What should I just put a 10 into here? What should I end up with if I did it properly? I should end up with 1. Show me 1. Bam. Any questions there? All right, so let's move to the free response, which you can tell from the percentages we're not very good. For number 14, not a lot, but let's say maybe 3 or 4 people in total attempted to do this one like number 3. Okay, where they and what they did was they got that initial amount and just multiplied it by the decay factor over and over and over again until you'd have to do it 42 times. Number 1, that's not practical. Number 2, this is why we have free response versus multiple choice. The multiple choice, you want to get away with it, go right ahead. But here you got to show you learned something. So in about how many years? You want to know how many years it would take for the car to be worth less than 10,000. So here's 10,000. What was it worth originally? What do you think, Yash? What was it worth originally? It's a tough question. 35,940. If it's depreciating by 3% per year, what's the decay factor? The decay rate is 3%, but what's the decay factor? 0.97. If you wanted to put 1 minus 0.03 first, that's fine, to the power of time. So whether you put 1 minus 0.03 or put this, either one of those gave you the first point. It's worth 4 points total. Writing the correct function gave you the first point. If you tried to do it manually after this and just get like 37,940 and times 0.97, times 0.97, times 0.97, and see how long it takes, I gave you that first point. If you got the right answer, I gave you the point for the answer, but you didn't get any points in between. If I wanted to solve it algebraically like I'm supposed to, what should I do next? Divide by 35,940. And here I was flexible, even though I've warned you several times, do not round too early, do not round too early, do not, if you're going to end up rounding, round because of the log, not because of a fraction. This gives you a long decimal. You can try to reduce it, but even then you don't have to. I would have just left it alone. Some people I noticed did reduce. I thought that was cool. That gave you another point by writing that. What's the next step? Take the log of 0.97 on both sides, log base 0.97, log base 0.97. That cancels out. The t has been isolated, so we get log 0.97 of 10,000 over 35,940. That's equal to t. That was your third point. And then when you put that in the calculator, log 10,000 divided by 35,940 divided by log 0.97. How many years did it take? Yeah. So T is approximately 42. Even if you did, you should have written years, but even if you didn't, I still gave you the point. 4 points. Writing all this down. And you can still write it. Nah. Okay, this next one, 15, completely condense. In order to condense into a single log, what has to be true? Same base and same coefficient. Now, what happened here, and this is, I'm sure if you go, I know before I started using this new software, it was hard to listen, but I'm pretty sure you could go find where I warned you. The two properties that are commonly confused are quotient property and change of base, because they both involve division. So I tried to stress what we use them for. Change of base is a way to evaluate a log. I'm not going to be evaluating any logs here. Quotient property is a way to bring logs together. So I want to bring these together. The first point, like what should be the first property I use here? That's a B, right? Log base B. What's the first property I should use? Power, good. I got to get that 2 and move it up. So this stays as minus log base B of W squared. On this one, if you just put the answer, I gave you all 3 points. Because I don't really think that there's a lot to gain from breaking them down into pieces. Like, you should know that the 2, when you're condensing, the 2 becomes an exponent. You should know that since these are positive, they're going to end up on the top, this is going to end up on the bottom. So even if you just gave me only an answer, even if you didn't write that and you just gave me the answer, I gave you all 3 points. Once you get this far, I think the easiest thing to do is just now write a single log base B. That's what we wanted. What's going to end up on the top, Julian, of the fraction? The U and the V. What's going to end up on the bottom? W squared. And if you did that, I gave you the last 2 points. If you broke it up into 2 steps, I gave you a point each. But this was the key. If you ended up with this, yes. Hence why I gave you all 3 points if you did it in 1 step. Those of you that just put the right answer on that one didn't have to show me anything else. I don't think there's anything to be gained or proven. Yeah, I mean, if you only put the answer and you either get, I doubt you guessed, but if you copied, fine. Then you know what? Good, congratulations. On that one, you can get away with it, but not the other ones. Any questions? Emily, any questions for you? Hang in there, Emily. Almost there. Solve the equation. Okay. Well, here, what type of equation is this? What type of equation is this? This is not exponential. I know this because it has the word log in it. You see the operation log. So what type of equation is this? Logarithmic. So that tells me at the end to check for extraneous. Of those 6 points, one of the 6 points came from the check for extraneous. Okay. What should I do first here? Since I have more than one log, what should I do first? Yes, you're right. Product property, yes, because we're adding. So log base 6, and if you could either just show the multiplication or just do the multiplication. X squared minus 5x. That was the first point, if you wrote that. Sadly, this is where now things went bonkers, and people that I expected more from just didn't know what to do next. How do you get rid of a log? Change to exponential. I saw a bunch of people that just did this. And just say, the heck with the log, I just don't want it. No. Change to exponential. That 6 now gets squared. This 2 becomes the exponent of the 6, and that allows the x squared minus 5x to break free. If you either did that or if you even just went ahead and wrote the 36, cool beans. Got a point for that. Because now if you identified it as being quadratic, it means that you made it equal to 0. You got a point for that. Now, the way you chose to solve it is up to you. So there were no points up until now you get the solutions. There were no more points given. I choose to factor here. This is x minus 9 and x plus 4. You should know by now how I got that. And then once we get into x is equal to 9 and x is equal to -4, those were the next 2 points. But that's 5 out of 6. Caleb, how do you have to get the last point? Check for extraneous solutions. Good. Okay, so I would go back to where I started at the very beginning, before any properties of logs or anything else was used. And let's try with the 9. Log base 6 of 9 minus 5 plus log base 6 of 9 is equal to 2. And see, like, if you at least write this is a minus. If you at least write that, and then you want to do the calculator for the rest, I gave it to you. I'm not expecting you to, and a lot of these, there's not a lot of steps to do. Like, it's going to rely heavily on the calculator, but at least I know what you're putting in the calculator. So if you just put now, hey, 2 equals 2 and it checks, sweet. But at the same time, you got to show me that the other one doesn't. So log base 6 of -4 minus 5 plus log base 6 of -4 it ends up not equaling 2. In both of those cases, you take a log of a negative. It doesn't work out. So if you did that, then you got the last point. Are there any other questions anywhere on the quiz? Sid, you know which one you got wrong? You know why you got it wrong? Cool. All right, so now let's go to a practice test. We won't be able to get through all of these, but we'll get through as many as we can. If you were here yesterday and you registered a score, by the way, the scores are on eClass. I know one person in here had to have found it yesterday because they already did the retake, but it was curved, so you have your raw score and your curved score. And then on top of that, if you want to do the retake, as long as you were here and took it and got a score, you can do it twice. And I will give you the higher of the 2 scores and average it with the one from yesterday. If you weren't here yesterday and you didn't take it, then you can just do it once. But you're doing it after the review, so we'll do as many as possible. This looks like the one that we did on the quiz, I think it was number 2. My decay, this is a decay because the decay factor is less than 1, but they want to know the decay rate. Basically, how did we get that 0.64? How did we get that 0.64? Okay, you could say 100 minus 64. It's really 1 minus 0.36, but fine, fair enough. Wait, I'm sorry. You said 100 minus 64? No. 100 minus 36. That's what gives you the 64. So this was a decay of 36%. You're losing 36% through every cycle. Hang in there, Zeke. You can do it, man. Do it for Slytherin. Yash. You know that Yash spelled backwards is H-say? If you ever go into hip-hop, that could be like your stage name. H-say. Did any of these problems yesterday look familiar to you? They were literally copied and pasted from the notes. I think one of them I copied and pasted from Delta Math. I might have changed some of the numbers to make them more user-friendly, but I think this one here is the exact same copy. I don't think this one I changed. And that's also supported by the fact that, I mean, like, if I would have caught it, I would have taken out that word graph. But when I did them on this exact one on the notes, I didn't graph either, so. A 1959 Gibson Les Paul guitar in 2000, it was purchased for $12,000. Experts estimate that the value is going to increase by 14% per year. So write a function, but then after you write the function, let's find out what the value of the find when the value of the guitar will be 60,000. So I want to know when the final amount is going to be 60,000. It starts off at 12,000. What's the growth factor going to be? 1.14 because it's increasing by 14%. And then, so if we were going to do this algebraically, what would we do first? Divide by 12,000. Alexi is an excellent divider. He's known around the world for his dividing skills. And that gives you 5. Question, Alexis, or stretching? So, Alexis, what do we do next? Lauren, next. How do we get rid of a base? Fantastic. Me likey. Very good. Log of 1.14 on both sides. Cancels out. Time is by itself. We want to round here. What property should we use to be able to evaluate this? Unless you have, definitely not power property, not quotient property. What's the property that we use for evaluating a log? Change of base. So this is when you do log 5 divided by log 1.14. And you get 12.28. So the amount of time it's going to take is 12.28 years. But if you started counting at the year 2000, what year would you be in after 12.28 years? You would be in 2012. Question, Sid? Because it said that it was that the value was increasing 14% per year. So the formula says 1 plus the rate of growth or decay. So that would be 1 plus 0.14. I just skipped to the 1.14. If it's decaying, if it's decreasing in value, it's minus, but it's increasing in value. The value of the guitar is going up. Questions? All right. How long will it take for 6,000 to triple in value? This was also straight from the notes. If you remember on the notes, the first time we did this, I said, okay, well, hey, what's triple of 6,000? 18,000? Okay, so 18,000 would be my final amount. 6,000 would be the original. You didn't have to. I'll show you now. You didn't have to start here. If it's 3% compounded monthly, 1 plus 0.03 over 12. I think this one on the notes, the percent was a little bit different, and I just made it easier for you. I think it was like 3.25. I just made it 3%. And then that 12 comes back up in the exponent with a time. So Yash, what are you going to do first? Or H-Stay, as he's known in the streets. Yeah, you could do that. And what happens when you divide by 6,000? You get the same 3. That triple that they were talking about, that's what you get when you get the old, the new divided by the old. But then if you want, in addition to that, you can go ahead and calculate what the growth factor is going to be. 0.3 divided by 12, and then if you add 1, I believe that gives you 1.0025. Tommy, what do you want to do next? What do you want to do next? Good, correct. Miles, what do you want to do next? No. Haseth? No, Lauren just did it. Lauren knows. Edvin, do you know? Good job, Edvin. Yeah, take that log of 1.0025, log of 1. So that knocks that out. You can go ahead and do change of base because we're going to have to. So log 3 divided by log of 1.0025 is equal to 12t. You can put that in the calculator and then divide by 12. If you wanted to be fancy, you would multiply by the reciprocal. So that over here you could put the 12 on the bottom. So this would be log 3 divided by 12 log 1.0025. And let's calculate that. Log 3 divided by 12 log 1.0025. Close, close. 36.66. If you notice the directions, round to the nearest tenth of a year. So how much time should it take? If you're gonna do the retake on these Google forms, I try to program it to take more than one like variation of the answer. Like if somebody just doesn't pay attention and put years, it should take it, but the safest way to guarantee you're gonna get it right is just put the number. So 36.7. But there's just a lot of factors. Did you spell years correctly, and did you put any extra spaces in there? Like, it's hard to account for. The only one I can guarantee you're gonna get right is if you put it without the unit. Okay, this was straight from Delta Math. So all those awesome homework grades that we get, you should have been able to get. And remember, these are the ones that were just missed the most. Julian invested $250 in an account paying 3% interest compounded continuously. That tells me that what formula am I going to use? Amount is equal to the principal times e to the power of RT. How long would it take? So I'm going to be looking for T. I got to put in for principal, for final amount, and for rate. So how long would it take to reach 320? 320 is the final amount. The principal was 250. E is a number, not a variable. The rate is 3%, 0.03 time. Landon, what would I do first? Well played, sir. You can reduce if you want and like cancel out the zeros, but that's gonna, well, that decimal might not be too bad. Put 32 divided by 25 and tell me what you get. What's 32 divided by 25? Is it a really, really long decimal? 1.28 exact? Oh, okay, so that's not too bad. All right, cool. We can do that as long as you're not rounding. How do we get rid of the e? Just ln. Just take ln. There's no need for change of base. No ln this over ln. Just bam, it's gone. And then the last step is going to be divide by a 0.03. I'm just trying to cut some corners here to finish so I can try to do more. So all I will put in the calculator is ln of 1.28 divided by ln of 0.03. All the children, whoa, that can't be right. What did I put? Oh, I'm sorry. I shouldn't have put the ln. Thank you. Sorry. ln of 1.28. Thank you. Just divided by 0.03. Thank you. 4.01. And now I put it wrong again. Alexi, it's all your fault. Sorry. ln 1.28 divided by 0.03. That makes more sense. All right, so 8.22. They wanted it around the nearest tenth of a year, so just 8.2. I can still do one or two more. Suppose you invest $1,600 in an annual interest rate of 4.6 compounded continuously. How much will you have after 4 years? Same formula, but now we want to know that final amount. 1,600 E. The rate is 4.6.0. 4.6 and 4 years. It's pure calculator. 1,600 E power and 0.046 times 4 close. 1923.22. Still got time. Can't remember the last time we did more than first period. I think that was the last one I got to in first period. So do a few more here. How much money invested at 5% compounded continuously for 3 years will yield? Ooh, there's a fun one. Is that 820? Does that say 820? Question mark. So 820 is the final amount. They want to know the principal here. So principal E 0.05 times 3. So here, all I'm really doing is just a division problem. That gives me 0.15. So all I got to do is divide e to the 0.15. So 820 divided by e to the 0.15. So I would have had to have started with 705.78 D. Last one. A boat costs $8,350 and decreases by 12% per year. How much would the boat be worth? Okay, oh, that's an easy one. Here. Oh, perfect. Let's do this one. This one was missed a ton. Solve each equation. What do you see? What type of equation is this? Exponential. And yeah, you can take log base 4 on both sides, but the whole point is if you take log base 4, you're going to end up with negative n is equal to negative 2n. There's n's on both sides. If you bring them to the same side, we get n is equal to what's left on the right side? Nothing. Do you have to check for extraneous? No. So and just on the Google form, just put the 0. I got 2 minutes. Let me see if I can do another one fast. I'm just giving you free answers. I mean, I'll stop if you want. Okay, here. Last one. Let's just do this one here. First step. Minus 7. So we get 5 times 12 to the 7k is equal to 33. Divide by 5. 12 to the 7k is equal, I'll leave it as 33 over 5. How do I get rid of the base of 12? Log base 12 on both sides. And then just to save time, because we're almost done, I'll just put it in the calculator, 33 over 5. So it's going to end up just being divided by 7. So log 33 over 5 divided by log 12, hit equals and divide that by 7. The decimal 0.10 right here. A. Okay, test tomorrow.